Hello, so we're gonna do the last question which is question 20. And this is a very interesting question. So it says the sum of the digits in the number 67 is 13, so we just add 6 plus 7, right? So it says show that the sum of the digits of the integers from 19 to 21 is 15. So we are given, so between 19 and 21, we just have 19, 20, and 21. So 1 plus 9, that is 10. 2 plus 0, that is 2. 2 plus 1 is 3. And 10 plus 2 plus 3, that is 15. Alright, so it says, find the sum of the digits of the integers from 1 to 99. Alright, so here's how we will think of this problem. Well, if I add, I start having a problem when I get to two-digit numbers, right? Like 11, because 1 plus 1 is 2. So I can do this first. I can add all these numbers here, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, without a problem. And if you add these together, you can use the arithmetic sum formula, whatever you want, you will get 45. Right? Or you can use Gauss's method. You can say, hey, 1 plus 2 plus, I have all the way until 9. If I say this is x, and if I reverse this, which is also x, I have this. If I add everything together, I get 2x, 9 times 10. That is 90, and therefore x is 45, right? Using Gauss's method, we see that the sum is 45. And this is an idea we have explored in the previous video. So now that we know that, let's try to identify these patterns in the digits, because we're adding the digits, we're not adding the numbers. Well, if I look here, the 0 is not going to affect anything. And, well, I can't really do it with 100. And I don't need to do it with 100 actually, because they said only up until 99, right? Yeah. So I don't need 100 there. So if I look at here, well, because I'm adding 0, 1 plus 0 is just 1, 2 plus 0 is just 2, this sum is also going to give me 45, right? And now, let's look at this. If I add this digits column-wise, I get 45, right? And the same goes for this column. So if I just partition from the middle, I see that on the left-hand side, all the digits are going to add up to 45. So I have 45 in the first row, right? And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 columns. 10 columns where I get 45. Now, I only have added these digits, the digits on the left-hand side, right? I have only added digits on the left-hand side. So I still need to think about the digits on the right-hand side. And if you think about it, if I now go row-wise, I have 1 left here, I have 2 left here. If I do the same for every column, I will have 3 left, 4 left, 5 left, 6 left, 7 left, 8 left, and 9 left. So I have 45 here once again. 45. And this is going to be 45 as well. So I'm adding the digits, remember. I'm not adding the numbers. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. And actually, if you consider the first row as well, that is 10 rows. So I have 10 rows of 45 and 10 columns of 45. So 10 rows of 45 gives me 450, right? So 45, you could also have done 9 times 45, right? 45 plus 10 rows of 45 plus 9 plus 45, but that is just saying 1 times 45 plus 9 times 45 is 10 times 45. So I don't need to write this. So this gives me 450, this gives me 450, and altogether I have 900. So that is the sum of the digits. All right, that is how you do question 20. So it's a very interesting problem, and it's very helpful when you draw it out so that you can visualize what you are doing. And if you were asked, well, find the sum of the digits from 1 to 100. Then from 1 to 99, it's already 900. So from 100, you just get 1 plus 0 is 1. So you would have gotten 901 if it was from 1 to 100. So that is 900 is your answer.